Good morning, all. Yeah, my name is Alex. I'm a well engineer in Halliburton project management. So the first part will be kind of general overview, what already been done previously in a couple of the geothermal projects, and also in terms of drilling deep wells and super deep wells. We will go through that, and then like some of the technologies that commonly used in the geothermal industry. So let's start. Yeah, we talk a lot about the geothermal, the benefits, and also how good this how will be good to use this energy worldwide. The only question how to scale, how to increase the scale, because it's like currently it's only like a couple of the places around the world, ring of fire, also very shallow wells in closer to the like volcanic regions or where we have like the magma closer to the surface. So currently that's the challenge, but the question is, can we replicate it in all the regions, in all the countries, in all the places around the world? So yeah, lots of studies was done, especially like heat mapping. Yeah, and the conclusion of these studies was if you can go deeper, we can reach higher temperature. Yeah, 7-10 kilometers depth. We can reach around like 200 degrees Celsius in most of the places. In places with a higher geothermal gradient, it will be around like 350 and probably even higher. So yeah, if we can go deeper, can drill deeper, so probably we can increase efficiency of the conversion of the thermal heat energy to the electricity. So, and the problem currently, if we drill oil and gas well, so we produce oil gas, we can sell it, so it will be like $100 per barrel. But when we drill geothermal wells, it will be just a couple of cents for like kilowatt hour. That's a challenge. That's why we cannot see. So this is levelized cost of energy on the y-axis, and here the time. And we can see that geothermal, conventional geothermal, the cost like usually the same. It doesn't like goes down. We saw over the last like 10 years the steep decrease in the cost for like solar energy, wind energy, because of the scale. So we started, it was initially costly, but then like some subsidies, technology advancement, and we can see this drastic drop in the cost of the energy. So the same expected for geothermal, not only for conventional, but also for EGS, AGS system, and also for the drilling deep geothermal wells. So oil and gas has some experience, accumulated over the last like 100 or 200 years, and it will be just good, as Tony mentioned yesterday, just to borrow technology, expertise, and knowledge and use and implement for geothermal wells drilling. Yeah, again, the slide with the cost, so we can see solar, we can see wind, but geothermal, it like stayed the same over the last 40 years. And one of the proposed concepts to drill deeper, to tap the formations with a higher temperature, it's going around. One evaluation was made. So, for example, with the 200 degrees C, we need to drill around 50 wells to generate 130 megawatts, but to achieve the same energy output, so we can drill just like 3 wells with the temperature around like 400 degrees C. So it's also about the investments and the outcome, what we're getting from those wells. Yeah, different type of wells. Just to mention, just recently appeared the concept of generating electricity based on the conversion of the temperature difference between the like tubing and the annulus. It's called thermal electricity conversion or generation, when we have like the thermal elements here, and kind of they convert the temperature difference into the energy. So currently it's just a concept, but it also could be used because the closed loop system we don't need, well, there is no communication between like reservoir, no issues and no risk of scaling and formation damage. So it's kind of promising technology. Currently, it's still under evaluation. Just to highlight that. And regarding the experience of drilling geothermal wells, so here some of the examples. So here we have conventional geothermal, Kenya, Indonesia, like Philippines, volcanic or sedimentary rocks, that we drilled already like for more than like 40 years. Nothing special, quite shallow. Formation hard, but currently it's like drilled without any issues. Some of the new projects, for example, deep project in Canada, sedimentary basin, it's like oil and gas field. They're good permeable reservoirs, so they drilled a couple injection or production wells. So they inject cold water and then water travel through the reservoir and they produce like hot water. The temperature is not so high; it's below 100 degrees C. But it's kind of pilot project that was currently like on the testing evaluation phase. So yeah, very interesting, promising. And another thing, some of the wells were drilled in Europe, Switzerland and Sweden. Very hard rocks as well, but they were drilled 20 years ago, around like 7 kilometers deep. And just recent one, OTN3, was drilled in Finland. Metamorphic plutonic rocks was difficult, very slow process. They tried different technologies, rotary drilling, percussion drilling. Finally they also like fractured the well and currently performed the test. And the recent one, Utah Forge, one of the unique wells in its kind because it's like deviated, drilled in the granite, the PDC beads were used there. And if we talk about not only geothermal but just deep wells drilling, so in industry, not so many wells were drilled over the last four decades. So, but here the most, I would say the deepest one, so Iceland, almost 5 kilometers depth. The temperature, the static bottom hole temperature was 530 degrees C. Some of the deep wells in Switzerland, 5 kilometers, Sweden, almost 7 kilometers, Finland, 6.5. And other wells, they were drilled in US, in Soviet Union. And the deepest one, the Kolar super deep, it was drilled from the top to bottom with in the crystalline basement. So the bottom hole temperature was not so high, only like 212 degrees C. At that time, 40 years ago, many new technologies at that time were tried, like turbo drilling, turbo drill, different types of bits, roller cone, but it also was poured from top to bottom. And currently, all the cores they're located like in the one of the warehouse. And people go and like the purpose of this well was not oil and gas, not geothermal. It was just pure research purpose. And the government invested money to know the history of the well and all subsurface. And as a colleague from Major Fields highlighted, to drill the well probably is not a big issue, but the well bore stability and how to pull the HA to the surface and then how to run the casing, that's kind of even more important. Some examples from the deep wells, Switzerland, like super deep, Kola super deep. One common thing between them is well bore stability. The deeper we go, the more critical well bore stability problem becomes, and because it looks like crystalline rocks, volcanic rocks, they should be stable and they should be like firm, but at the same time they could have lots of microfractures and also capillary effect, we cannot eliminate them. So this 12 kilometers well, so we drill deeper and then we can see the well bore volume.
8.5-inch hole size, but at the bottom it was like almost 2 or 3 times bigger. Yeah, it was not very fast drilling. Yeah, 40 years ago, very slow process, drilling process. So but again, it's just we need data. We need to be prepared to drill such kind of wells. And considering the latest news about the geothermal, so in the upcoming decade, should be lots of projects around the world because lots of companies, lots of governments, they announce they have net zero target and they're ready to invest in geothermal. And here, just a summary, summary of the companies, of the startups who invest in the new technology of drilling. So like laser, plasma, electromagnetic waves, abrasive jet. So that's just some of them. But still rotary drilling, yeah, what we use in oil and gas is still kind of primary because here all these technologies they still will take some time to come to the industry to kind of get some confidence to use them for the wells. And yeah, so can we go to the second part? Yeah, okay. So this was just overview, geothermal wells and deep drilling. So technology, expertise already there. We just need to kind of borrow and use basic already accumulated experience for like any other project. In terms of Halliburton technologies, I already mentioned yesterday. Yeah, drill bits is a key because they're hard, metamorphic, abrasive rocks, and but we cannot say that like these people will work there. We need evaluated data and we need to have like at least trial run. More and more drill bit engineers, so they're confident in PDC. And because it looks like there is no limitations for them, yeah, because they already proved that they can drill granite and also some of the very like hard rocks. And that's just like one of the examples how, like in Indonesia, everyone was afraid initially to run the ECB. But once they run, and after a couple of trials, so they modified the design, they made some adjustments, and after that they achieved the longest run with the highest ROP. And I have some statistics here. Yeah, Indonesia, 38 wells, Philippines, 16 wells were drilled over the last 5 years. And here's a comparison. So this meters drilled per bit, roller horns versus PDC. And so we can see the footage drilled per bit for PDC is like 3 or even like 4 times higher. 800 versus 200 meters. The same with ROP. ROP for PDC, 3-4 times higher, 20 versus 5. And you see the number of bits, 25 rounds versus like 84. Initially, yeah, it was kind of, there was no confidence, but now every well was currently drilled with the PDC. The design already kind of proven, still some adjustments made with the cutters, with the like number of blades, but it's kind of continuous process. We cannot do it like in the same well. Usually it requires like some time. And also we cannot, for some conditions, still roll on is the best fit because they still can provide higher ROP and the longevity of the bit is higher. And here, bottom hole temperatures are rule of project, 500 degrees Fahrenheit. So, and no issues with the sealing, and bit comes out to the surface with the sealing and pairing is like fully effective. Here, again, Philippines project. Again, red one is a PDC bits. The PDC bits, you can see this footage, and the blue dots is an ROP. So it's like couple of times higher ROP, and like from casing shoe to TT in one run. So it's like big difference, and yeah, the bits were working there. So again, design is important. We cannot say that this bit will work 100% like in Taiwan. there will be some adjustments made. We need to analyze lithology, the stroke strength, and the previous experience. But after that, even PDCB should work there. And our guys in the office, so they kind of take it as a challenge. So they are ready to run, ready to try, and see the results. And first run actually was not so good. It was good ROP, was good footage, but you see design C after like a couple of trials, some adjustments. Yeah, they kind of set the record. In terms of roll-on beats, some of the records also like different sizes, 17.5, 12.25, 8.5. So Indonesia, Philippines, and Vietnam, one of the examples of drilling like hard granite, also abrasive, very highly fractured. It was drilled May 2005, so no issues at that time. So currently, 20 years later, so even with more advanced technologies, we should be able to build really well. From directional drilling, you see here conventional tools that we're using in oil and gas. They usually use to drill geothermal wells. Only like in not significant amount of the high temperature tools used to drill geothermal. More expensive and also like sometimes more expensive and sometimes just no need to use them because circulating temperature is still below 150 degrees C. And one of the issues, as we discussed yesterday, is like losses, but for directional drilling department, usually electromagnetic telemetry used to see where we're drilling and like adjust the well path and trajectory like in real time. And we can drill, like hole cleaning will be an issue if we have losses, and with electromagnetic telemetry we can drill and pulse with the air, foam, or like nitrogen. You will inject from the surface to clean the well. So, and what else? And cementing, 350 degrees
Fahrenheit, so kind of no issues with the cementing, and even higher, there are like some cement slurries that are applicable for like even higher temperature. So some of the technologies here, also for that. Sometimes there is acid gases in the like reservoirs, so we also need to design like cement slurry to prevent like corrosion and degradation of the well, because like wellbore integrity over the long time also critical for geothermal wells. I think that's all. Some of the case studies we reviewed yesterday during the end of the presentation. If you willing to like discuss or see more details, we just should have like separate session and go through details. So that's all from my side. Thank you very much.